This is a key to topic 29, worksheet 2. And on worksheet 2, you want to graph these exponential functions, and there are two of them. So number one is 1/3, where the base is 1/3 raised to the x power minus 4. And the second function is where you have the negative and then 2 to the x plus 4. So let's look at number one. I'm going to go ahead and rewrite number one here. And so number one, we have this function f of x is equal to 1/3 raised to the x power minus 4. All right, now remember the direction says this, though. It says plot at least 3 points on the graph and then draw your horizontal asymptote. And then you also have to answer all these questions. All right, so remember, for all exponential functions, the domain for all of them, the domain is going to be all real numbers. So the domain for exponential function is all real numbers. So domain here is all real numbers. All exponential functions have domain all real numbers. I can use any number for x and I'll get a y value. Now, in part B, they want you to find the range, and in part C, they want you to find the horizontal asymptote. Let's do the horizontal asymptote first. The horizontal asymptote is always the easiest to find because it's always this constant right here. So this constant is a -4. Now remember, when indicating the horizontal asymptote is a horizontal line. So when naming a horizontal line from previous courses, it's always y equal. All right, so the horizontal asymptote you're going to say is y equal -4. So that's your horizontal asymptote. So y equals -4. Okay, now, so I'm going to go ahead and graph this right now. So I'm going to graph this, y equals -4, so that's right here. All right, use a dotted line. Okay, now, here's the next thing you got to ask yourself. Is the graph going to be above or below? That's the next thing you ask yourself. And that's going to help you with the range. Is the graph above or below? Well, since there's no reflection, see here, there's a reflection. See that negative? So there's a reflection about the x-axis. Here, there's none. So the graph's going to be above the horizontal asymptote. So therefore, since the graph's above, you always start from the horizontal asymptote. Now remember, the graph does not touch the horizontal asymptote. So it's going to be from -4 parentheses all the way to infinity. So that's how you determine that. So -4 all the way to infinity. The y-intercept, remember it says plot at least 3 points, right? Well, the y-intercept, an exponential function always has a y-intercept. An exponential function always has a y-intercept. So there's one of your points. So to find the y-intercept, remember you let x be 0. So in part D, you're going to let, to find the y-intercept, you're going to let x be 0. All right, now when I let x be 0, so I get y equals 1/3 to the 0 power, because I'm letting x be 0, to the 0 power minus 4. Well, 1/3 raised to 0 power we know is 1, and 1 minus 4 is a -3. So my y-intercept is -3. Now, if you want to write this as an ordered pair, you can write it as x is 0, y is -3. All right? So my y-intercept is -3. So right away, I know one point of the graph. So I know that my graph's going to cross the y-axis at -3. So there's one of my points right here. I need two more. So remember, to do the two others, you're going to use a t-table. Use a t-table. And so here's what I want you to think about those. So think about what values of x will help you, will make things easier for you. Okay, so we know the graph's above the horizontal asymptote, but then what we also need to know, though, is the graph going to decrease or is the graph going to increase? So since the base is less than 1, I'm going to write it here. Since the base, which is 1/3, is less than 1, since the base is less than 1, f of x is decreasing. Okay, so it's going to do something like this. All right, so what I'm going to do is I'm going to pick some negative numbers for that, because I know that since it's decreasing, this part's going to go towards the horizontal, just like this. So I don't need any more points on this side. I just need a couple more on this side. All right, so that's the way you think about this. You know the graph goes towards the horizontal asymptote. You know that since the base is 1/3, which 1/3 is less than 1, it's going to be decreasing. So do this. So let's go ahead and let x be -1 and -2. So if x is -1 and x is -2, let's see what happens. Use your calculator if you need to. So I get 1/3. So 1/3. 1/3 raised to the -1 power minus 4. All right. Now I want you to think about this. You had these ideas in a previous course. Remember 1/3. Recall 1/3 raised to the -1 power, or any negative power. Since that exponent is negative, you want to make that exponent positive. One way to make that exponent positive, since I have a fraction here, is to take the reciprocal of that fraction. Well, the reciprocal 1/3 is 3, so I get 3 to the first power, which is 3. So whenever you have a fraction raised to a negative power, one way you learned to make that exponent positive is to take the reciprocal. And it kind of makes sense, because if you do use your calculator in this, watch what happens. So in parentheses, I'm going to say 1 divided by 3, close the parentheses, and we're going to raise it to the -1 power, and watch, you're going to get 3. You get 3 as your answer. All right, so this is going to be 3 minus 4 now, which is -1. So I get the point -1, -1. So that's right here. So there's another point. Okay, I need 3 altogether. So let's do -2. Same idea. I'm going to have 1/3 raised to -2 power minus 4. Now, we all know that since the exponent is negative, I want to make it positive. To make that exponent positive, I'm going to take the reciprocal of this fraction. The reciprocal of 1/3 is 3. So I get 3 squared minus 4. Well, 3 squared is 9. 9 minus 4 is 5. So I get the point -2, 5. So -2, 5 is right here. Okay, now let's go back over this again. In previous courses, when you dealt with negative exponents, we always wanted to make those exponents positive. Well, to make that -2 positive, you're going to take the reciprocal of that base. The reciprocal 1/3 is 3. So now I get 3 squared. 3 squared is 9. 9 minus 4 is 5. Now, if you want to check on your calculator, that's easy to do. You say, that's 1/3 -2. You say parentheses, 1 divided by 3, close the parentheses, and then raise to the -2 power. Notice what you get. You get 9. And that's what we said. All right. Okay, and then now all you do is just draw your graph. Now make sure you draw arrows. Don't stop here. Okay, so now be careful. Do the best you can with drawing this. Make it look like an exponential. Don't forget your arrow, and there you go. There's the graph. And notice you can tell that I had plotted 3 points. 1, 2, 3. See, it's darkened. All right, so make sure I can tell where your 3 points are. All right, and so that's number 1. Okay, so let's do number 2. In number 2, we have this. In number 2, we have this function, and I'm going to go ahead and write it out. So our function here is g of x equals -2 to the x plus 4. All right, now remember, this negative out here is a reflection about the x-axis. So if we were to cover it up, and let me go ahead and quickly. Okay, so if I were to cover this part up, remember, here's your horizontal asymptote. Since if there were no reflection, the graph would be above the x-axis. Well, since there's a reflection, the graph is below. All right, so keep that in mind. Okay, now let's go ahead and answer those questions. So let me quickly find the page. So you want to find the domain. All right, so the domain, remember, since this is an exponential function, the domain, this is number 2, the domain is all real numbers. Okay, all exponential functions, the domain is all real numbers. Okay, now part B, they want you to find the range. Part C, they want you to find the horizontal asymptote. All right, and let's do the horizontal asymptote first. The horizontal asymptote is easy. That's this number here. Okay, this constant. And so it's going to be y equal 4. So I'm going to go to my graph. I'm going to draw the horizontal asymptote y equal 4. So here's y equal 4 right here. Okay? So that's y equal 4. And the domain's negative infinity to infinity. Okay, now the next question you ask yourself is to determine the range, is the graph above or below the horizontal asymptote? Well, what I was making a point of was this. If that negative wasn't there, then we would say, let me go ahead and rearrange this, then you would say that the graph would be above the horizontal asymptote. Well, remember that negative reflects it about the x-axis. In this case, if it's up, if it wasn't there, then it will be below here. Okay. So so um, so then we know it's going to be below the horizontal asymptote. All right, now so I know that the range then, since the graph is below the horizontal asymptote, I know that the range is going to be from negative infinity all the way to this horizontal asymptote. So it'll be negative infinity to 4 with parentheses, not bracket, because remember the graph does not cross the horizontal asymptote or touch it. It gets closer and closer and closer to it. Okay? All right, now, so then, Lynn, let's go back over this again. So remember, this is an exponential function. So the domain of all exponential functions is all real numbers, so negative infinity to infinity. The horizontal asymptote we found next, because that's always the easiest to find also. The horizontal asymptote is y equal 4. Now remember, if there's no reflection, then the graph will be above the horizontal asymptote. Since there's a reflection, you're going to reflect it about that horizontal asymptote, because the horizontal asymptote is 4. So you're going to reflect it about that horizontal asymptote. So instead of being above, it'll be below. Okay? Now, here's what I want you to think about. So we know the range now. So we know the range is negative infinity to 4 with parentheses, because remember the graph does not touch or cross the horizontal asymptote. What I want you to think about now is this. So we got to graph this now. So I know the graph is below the horizontal asymptote. So the question is the graph decreasing or is the graph increasing? So is the graph decreasing? So is the left side going this way or is the right side going this way? All right, now let's go ahead and first of all find the y-intercept. So the y-intercept is, you're going to let x equal 0. Now be careful with that. Remember, you have this. So let me go ahead and write it on here. So the y-intercept, you're going to let x equal 0. So we have y equal negative 2 to the 0 plus 4. 2 to the 0 is 1, so that's a negative 1. Make sure you understand that. Plus 4, and negative 1 plus 4 is 3. So my y-intercept is 3, or you can say 0, 3. So I know that the graph's going to cross the y-axis at 3, right here. So here's one of my points. So what I'm saying earlier was, is the graph going to do this? Or is the graph going to do this? Is the graph going to increase or is the graph going to decrease? In our lessons, this is what we learned. We learned this in our lessons. So if there's no reflection and you look at the base, since the base is greater than 1, 2 is greater than 1, then that's an increasing function. So in our mind, let me go ahead and think that. So if remember if there's no reflection, then the base is 2, that's an increasing function. So in our mind, we know it's going to do this. So let's say that's a horizontal asymptote right here. If there's a reflection, then it does this. So it goes from increasing to decreasing. So the reflection reverses what's happening if there was no reflection. So since this is greater than 1, the graph is increasing, the exponential function increasing. Since I am reflecting it though, it's supposed to be decreasing now. So I know in my mind that it's going to do this. And so since it's going to do this, then I know this side is going to do this. Okay? And all I got to do now, remember I need 3 points, so all I'm going to do now is use 1 and 2. So I'm going to let x equal 1 I'm going to let x equal 2. All right, so if x is 1 and x is 2, let's see what happens. So if x is 1, I'm going to go and do this right here. If x is 1, I get negative 2 to the first plus 4. Well, 2 to the first is 2, so I get negative 2 plus 4, which is 2. So I get the point 1, 2. So that's this right here. Okay? If x is 2, I get negative 2 squared plus 4. Well, right here, 2 squared is 4, so that's a negative 4. So be careful. Remember, when dealing with exponential functions, don't say the base is negative 2. So remember, the base of an exponential function can never be negative. The base of an exponential function has to be positive. So you see it's positive 2 here. But 2 to that x value, you're going to make it negative. But the base is not negative. The base is positive. So you got to understand that. So in your calculator, you got to be careful. Some students will say negative 2 squared is a positive 4, and that's incorrect. And even if you did do that, you say 4 plus 4 is 8, you know something's wrong, right? Because when x is 2, you're going to get a point up here, and you know your graph can't do that. It can't go here and all of a sudden jump that way. So you know you did something wrong. So negative 4 plus 4 is 0. So we get 2, 0, which is here, and you have enough points now. Just do the best you can with graphing this, and so there's what you get. Okay? And so there's your graph. All right, so my y-intercept, remember, was it was 3, and so that's where we let x be 0. Okay? And so that is it. So that is the key to topic 29, worksheet 2.